MOXIE, and in this final lesson of this segment, we're going beyond the ordinary, which is into the wide side of physics. So far, you've learned about motion, energy, heat, and electricity. All these things we can see or feel. Now, let's take a bold step into the mysterious, where space bends, time slows down, and matter turns into pure energy. Welcome to the world of Einstein and modern physics. Have you ever wondered what would happen if you could travel close to the speed of light? Have you? Would time change for you? Would your body stretch and shrink, right? Well, believe it or not, physics has the answers. By the end of this lesson, you'll be able to, 1, describe what Einstein's equation E equal to mc² means in simple language. Number 2, you'll be able to understand how matter and energy are related. Number 3, you'll be able to appreciate how physics explains the most amazing phenomena in the universe. Think about this. What if a tiny piece of matter could release the same energy as a thunderstorm? Sounds impossible, right? Well, that's exactly what Einstein showed us, right? When you start studying physics, you often begin with things you can touch, which are moving balls, falling objects, the warm cup of tea. But the deeper you go, the wider it gets. That's where Albert Einstein comes in. Albert Einstein is one of the greatest minds in physics and a true symbol of genius, right? So, what exactly does the famous equation mean? It says that energy E and mass m are actually two forms of the same thing. They can be converted into each other using the speed of light squared, which is c raised to power 2, as the conversion factor. Now, what this means is that matter can turn into energy, and energy can turn into matter. It's not science fiction. It's happening right now in the sun. Every second, the sun converts about 4.79 million tons of matter into radiant energy. This is the light that travels all the way to Earth. That light warms you, powers plants, and keeps life alive. But the wideness doesn't stop there. As objects move faster, especially near the speed of light, the universe itself starts behaving differently. Imagine a spaceship flying almost as fast as light. To someone watching from Earth, the spaceship looks squished, which means shorter in the direction it's moving. That's called length contraction. And time itself, it slows down for the people inside the ship. While 200 years might pass on Earth, only 2 years passes for those in the ship. That's time dilation. Sounds crazy, right? It's pure physics, tested, proven, and real. Einstein showed that space and time are woven together into a fabric called space-time. And when you move closer to light speed, that fabric bends and behaves differently. And if you think that's wide, wait till you hear what happens next. At the edge of the universe, physics predicts things like black holes, where gravity is so strong that even light cannot escape, and possibly wormholes, which are shortcuts through space that could, in theory, connect distant parts of the universe instantly. These are the frontiers of modern physics. Ideas that sound like science fiction, but are built on real mathematical science. So whether you're studying a falling ball or the bending of time. Remember this, physics covers it all, from the simplest motion to the most mysterious corners of the universe. All right, let's see what you can recall from this wide ride. Question number 1. What does Einstein equation E equals to mc power 2 raised to power 2 tell us? A, mass and energy are unrelated. B, matter and energy are equivalent. C, energy comes from heat. D, light has no energy. Question number 2. What happens to time on a spaceship moving near the speed of light? A, time goes faster. B, time slows down. C, time stops completely. D, time repeats. Okay, here's something for your imagination and a little research. Okay, 1. Find the one real life example where E equal to mc raised to power 2 is applied. Take for instance, the sun or nuclear power. Now, number 2, in your notebook, write a short explanation in your own words of what energy and mass equivalence means. Okay? All right, drop that also in the comment section so we'll be part of your journey. And that's it. You've just completed the first segment of our physics journey. You've seen that physics isn't just about numbers. It's about understanding your world. From motion and heat to electricity and relativity. It is all connected. I am MOXIE. Thank you for learning with me, and get ready because we're just getting started.